Hi everyone! Today we're going to see how to dynamically call a process and how to define process variables in TIBCO. Let's start with dynamic processes. We'll revisit the examples from last lesson on operations. We'll change the schema's input and output so that there's an identifier for each operation. For this example, we'll create 4 subprocesses, each with its own operation. It's crucial that these processes have the same signature, meaning the same input and output. So we'll create the sum process, defining the single operation as input and the single result as output. We'll insert a mapper that manages the operation's logic, which, in this case, is the sum. In the end palette, we'll copy the mapper's output. Now we'll copy and paste the process for the remaining 3 operations, changing the name and the operation's logic. Attention! The process's name must match the name of the operation in input. In the division process, we'll insert the logic to handle the impossibility of dividing by 0. In the timer, we'll insert a mapper that has multiple operations as input. We'll copy and paste the XSLT of the process call seen in the last lesson. We'll add a second mapper that automatically populates the IDs with the index, using the position function to ensure uniqueness. We can also concatenate the name of the operation itself. We'll change the process's referencing, making it point to one of the newly created processes. This will ensure that the appropriate signature is used. We will change the reference to the process with one of the 4 subprocesses created. In the log palette, we print the output of the process call. We'll select the process call and the log palette and insert them into an iterate group. For those who don't remember, we already talked about it in lesson 3. As iteration, we'll choose the repetitive element that comes from the mapper ID. So as input to the process, we'll insert the operation of the current element. We'll copy the name of the package in which we inserted our processes in the processes general section. We'll click on associated with process name dynamic override. Here, we'll insert the concatenation of the package and the name of the operation in the current element. We'll launch the debug, making sure to flag all the necessary subprocesses, otherwise they won't be executed automatically. As you can see, for each iteration, the processes with the associated operation's name were called. But what happens if we insert an operation for which a subprocess doesn't exist? It will give us a process not found error, which we can handle with an exception from the error branch. As seen in lesson 2, in case of exception, we'll print the error message and insert a transition that leads to the group's end, so that the iteration can continue. Please support us by liking the video and subscribing to the channel. Now let's discuss process variables. These variables can hold simple data types like integers and strings, or even complex XML documents. Their life cycle is limited to the specific process they belong to. For instance, a called process remains unaware of their existence. In the timer process, in the process variable section, we'll create two types of variables. One of integer type with a default value of 0, which we'll call timestamp, and one that references the output schema, which we'll call output. The first one has the purpose of recording the time in milliseconds it took to execute the operations, while the second one has the purpose of containing the outputs coming from the various operations. We'll insert a log output in which we show the difference between the current timestamp and the timestamp coming from our variable. We also log the output variable using the render XML function. We'll insert the assign palette, referencing it to our timestamp, inserting the timestamp function as input. Now we'll introduce two assign palettes, both in case of successful operation and in case of error, referencing the output variable for both. If the operation was successful, we'll insert the result in the subprocesses output. In case of error, we'll insert the error message. By doing so, however, the result will be overwritten for each operation. What we need to do is copy the previous results in the palette that come from the same output variable. So for both, we'll duplicate the repetitive element and copy what the variable had in memory. In this way, we won't have loss of information. In the log output, it won't be necessary to choose from which of the two assigns to take the input, since the two assigns are not visible, but only the output variable is visible. We'll launch the debug. In the log end, we see the time elapsed in milliseconds. We'll copy the message's value and paste it on Notepad. The results are in reverse order because in the assigns we first inserted the result and then the copy of what was there before. To solve this, we can either delete the mapping and redo it, or we can act on the XSLT by changing the position of the copy of and bringing it to the first row, then click Parse. In this way, the order is respected. We'll save to relaunch the debug and recopy the message's value in the log output on Notepad. As an exercise, I'll leave you with the task of adding an additional operation, the modulo operation, recreating it yourselves. You'll find a small mathematical hint in the description on how to do it. Thanks for your attention. For any questions, feel free to comment below. If you enjoyed this video, please like it and subscribe to the channel.